Building AI products in 2026 means moving way past simple chat prompts. We are now asking systems to execute multi-step, autonomous workflows. Right now, two major models are dominating that new standard: Anthropic's Claude Opus 4.7 and xAI's Grok 4.3. For developers and enterprise leaders, choosing between them presents a stark trade-off. You either pay a premium for Anthropic's deep, deliberate logic, or you lean into xAI's aggressive pricing and speed. If you misalign your project with the wrong ecosystem, you will burn through your API budget quickly, and you still won't solve the actual friction points slowing down your team. You might be tempted to just look at standard intelligence scores to make your decision, but those numbers are increasingly misleading for real-world application building. A developer trying to untangle a race condition across 20 different files needs an entirely different kind of processing power than a marketing director who just needs to generate a clean client presentation by Friday. If we map out the true landscape based on utility versus logic, we find Claude Opus 4.7 sitting squarely in the top right for premium, deep reasoning. Grok 4.3 commands the bottom left for high-speed, low-cost utility, with OpenAI's GPT-5.5 bridging the middle. Figuring out which corner of that map you belong in requires looking closely at your specific daily tasks and seeing how they align with how these models were built to think. Selecting the right tool requires aligning the model's underlying architecture directly with your team's specific friction points. Let's look at Claude Opus 4.7. Anthropic designed this as a strict architect-level system specifically for complex coding and autonomous agents. To get there, they introduced a new effort parameter called xhigh, which forces the model into a deep, adaptive thinking mode before it writes a single line of code. This chart shows the agentic code behavior scores for Opus 4.7. As you can see, it outpaces or matches its predecessors across instruction following, verification, and adaptability. It actually writes a solution, runs a simulated test on it, and fixes its own bugs before showing you the final output. That self-checking process is exactly why it dominates the SWE-bench coding evaluations. But that deep reasoning cycle creates a very specific operational trade-off, a massive delay in time to first token. If you are building a product that streams responses to users, that pause will feel incredibly long. And there is a hidden pricing trap. Opus 4.7 uses a new tokenizer that can consume up to 35% more tokens on the exact same text prompt compared to Opus 4.6. While the base price looks flat on paper, that tokenizer change means Opus 4.7's reliable execution actually comes with a steep tax on both your time and your API budget. Opus 4.7 also moves the model family into high-resolution vision support. It now accepts images up to 2576 pixels on the long edge, giving it the ability to read interfaces with precision by creating a direct one-to-one mapping with actual pixels. If you are running computer use agents that need to click on dense spreadsheets or read tiny UI text, this eliminates the complex scaling math that caused older models to constantly misread layouts.
However, feeding raw 3.75 megapixel images into a context window will spike your token usage incredibly fast. If absolute visual fidelity isn't strictly necessary for your task, you have to downsample your images first. Otherwise, the token costs will quietly destroy your project's return on investment. On the other side of the spectrum is Grok 4.3. This is a high-speed, utility-focused alternative built for time-poor prosumers, marketers, and analysts. Its defining feature has nothing to do with deep architecture. It's the ability to generate finished, native documents directly within the chat interface. You can ask for a market report, and it will output a direct downloadable PDF, a populated spreadsheet, or a formatted PowerPoint deck. The design trade-off here is obvious. The output is highly functional and cleanly structured, but it lacks the final visual polish you would normally present to a high-level client. Grok's utility lies in eliminating the manual copy-paste workflow, delivering a functional first draft you can download and refine immediately. Grok 4.3 also aggressively targets API economics and processing speed. When compared to Opus, Grok runs at an incredibly fast 159 tokens per second and costs just $1.25 per million input tokens. But there is a catch. Grok operates with an always-on reasoning mechanism that you cannot manually turn off. Because of this, you are forced to burn billable output tokens on hidden reasoning cycles, even when you are asking incredibly simple, basic queries that don't need deep thought. You also need to watch your prompt length carefully. Once your request crosses the 200,000 token threshold, the per token price immediately doubles. Grok 4.3 delivers the lowest operational costs in its class, assuming your team maintains strict prompt hygiene and manages context limits. So, how do you actually decide which model to integrate into your stack today? Every deployment decision right now hinges on one defining question. What is your primary output? Code or documents? If your goal is to resolve multi-file race conditions, construct complex software architecture, or run autonomous agents that verify their own work, you need Claude Opus 4.7. On the other hand, if you need to quickly generate reports, build high-volume API applications, and keep your context lengths under 200,000 tokens, Grok 4.3 is your target. There is no universally superior model here. The right choice depends entirely on identifying your team's specific operational bottleneck and applying the architecture built to solve it. With Anthropic, you have to absorb a 35% token penalty and slower response times to secure flawless implicit need resolution. With xhigh, you accept a slightly lower intelligence ceiling in exchange for disruptive pricing and the ability to generate native files instantly. Navigating these hidden token traps and highly specific feature sets is the reality of building viable AI products in 2026. Choose your architecture, plan for the hidden costs, and start building.